This video is for the Argonia Cup competition. This video is for one of the teams from the University of Illinois at Chicago. Our team name is Team 1. Our team number is 2108. This rocket is a simpler design than the other team from our university. This rocket is going to be 3 inches in diameter. It is going to be a minimum diameter design. We're going to put the golf ball inside the rocket, and the golf ball is not going to leave the rocket. I have previously talked to the organizers of this competition, and they have told me that the golf ball does not need to leave the rocket for this competition. So we're just going to have a simple design. The rocket goes up, it comes down. We have a safe flight, and wherever the rocket lands, that's where the golf ball is. Now we're going to hear more later in the video about the electronics components of a rocket and the overall rocket design and the flight simulations. Thank you.
This is the open rocket file for our 3-inch diameter rocket. It has a total mass of 15.6 pounds with the motor, and the motor we are using is the Aerotech K1000T-P motor. The total length of the rocket is 77 inches and has a stability of 3.51. The estimated apogee is 9,545 feet, and our rocket will reach a maximum of Mach 0.97. Here is the flight simulation for the rocket. Below is a graph, and in the graph, the red line signifies the altitude, the yellow is the total velocity, the vertical acceleration is shown in green, and the vertical velocity is shown in blue. Both the vertical acceleration and vertical velocity even out after the motor burnout is complete. The estimated time to apogee is 22.6 seconds, and the total flight time is approximately 52 seconds. The velocity of the rocket off the rod will be an approximate 110 feet per second. The thrust to weight ratio is 14.41.
For the rocket, the main parachute and ejection charges will be placed forward of the avionics bay coupler, while the drogue parachute and ejection charges will be placed aft of the coupler. The avionics bay houses the brains of the rocket, comprising of a battery holder for the 9-volt battery, the stratologger, and the terminal block. The avionics bay also had to adhere to several design conditions which forced us to undergo various changes to our design, trying out different placements of components, lengths and heights, and orientation of components. The various restrictions included an absolute size limit of 2.95 inches to minimize the space the avionics bay would occupy. The avionics bay also required a system that could house a double redundancy system. To accomplish this, we created a double-plated design where the primary and redundant altimeters will be housed and be protected from the direct forces of the ejection charges. For the avionics bay, we chose to 3D print the rod holders and laser cut the plate out of plywood. The reason for our choice in material was that the 3D printer would allow us to freely change the design for the rod holder, and the plywood cuts down on production time and also allows for a sudden design change in the case of an emergency. The final variation of the design resulted in an avionics bay that fits rather comfortably into the rocket at 7.3 inches tall and 2.33 inches in length. Based on online and hand calculations, the main compartment will require about 1.5 grams of black powder, and the drogue compartment will require 2.5 grams, with both compartments requiring shear pins. The difference in these values stemming from the different masses of each section.